Let's have a look at some basic examples now that employ right-angled trigonometry to find a missing side in a right-angled triangle. Okay, of course you'll need your calculator with you, of course. Alright, let's have a look at these three examples. So we have part A, okay, right-angled triangle, we've got a hypotenuse, okay, we have an adjacent side. Now, if you're unsure as to which side is which, okay, I suggest labeling the triangle first, okay. Your theta is always where the angle is, okay, so that you could label this as your theta here, okay. That's your theta. The longest side is always the hypotenuse, so I'll just put a letter, just a H there. Okay. Now the side that we want is the side that's in fact closest to theta. So this is our adjacent side. Adjacent means next to, so or closest to. So adjacent is next to theta. This is the opposite side here, but notice that the opposite side is not involved at all. So we don't actually care about it. Okay. So we're not going to involve that. Okay, now if you forget which ratio is which, and if it's not given to you, okay, I'd probably suggest writing this down somewhere. Okay, just write down SOHCAHTOA somewhere on your page, or have it next to you somewhere. Okay, now we have a hypotenuse. We need the adjacent side. Okay, AH. Go back to SOHCAHTOA. You can see that we have an AH here. Look at the letter before the AH. It's a C, so it's cosine. So first thing we do is write down the ratio. Okay, so cos of 50 degrees is equal to adjacent over hypotenuse. Okay, so it's going to be x over 25. Now we solve it as a regular equation. Okay, we want the x to be the subject of the formula. So we're going to move this division by 25. X over 25 means x divided by 25. We're going to move the 25 over to the left-hand side. We're going to turn it into a multiplication. Okay, so 25 cos of 50 degrees is equal to x. And now we can enter it into the calculator to get a, actually I might just move the board over just a touch there. Hopefully you can see the screen. I might just brighten the video just a little bit there. Hopefully you can see that okay. Yep, okay, so 25 cos of 50. You don't have to put the degree symbol there, just it's assumed it's degrees, is equal to 16.06. So x is equal to 16.0696 ... But we want it to one decimal place, so that's going to be 16.1. Okay, I didn't put units like centimeters or meters or whatever the units are. Just continue on. Just express the answer in the correct units. Now, just quickly. Some people have been caught out with this before. Okay, have a look very closely. Hopefully the camera can adjust. Just that little symbol there. Let me just see if I can readjust the camera. Sometimes it. Yep. See that D? Okay, the D. So this D here. Okay, that D there. It needs to be D. D is for degrees. Now sometimes, let me just get the calculator into a different mode. Sometimes this can come up. Okay, so. And okay, hopefully you can see that okay. I'll just readjust it. Yeah, you see an R, okay? We don't use that, okay? We don't use that until year 11 sometime, okay, in advanced mathematics. So if your calculator ever shows that, okay, what you can do, either do a factory reset on your calculator, or just go Shift, Setup, and option number 3, okay, for degrees, okay, and a little D will come up there. Alright. Let me just readjust the focus on the camera there. Yep, that's better. Excellent. Let's continue. Part B. Another triangle. Okay, we have an angle. This time we don't know what the hypotenuse is, but let's label the triangle just so we know which trig ratio that we're going to use. We have the. You know what? I'm going to change it. That's should have put it here actually. So I'll do that now. All right. Yes, I can change a question midway through. Actually, no, only kidding. That was a mistake, so I should have had the 18 there. Alright, so looking at that, let's label size. I've got the hypotenuse, that's okay, that's fine. The 18, well, that's well over the other side, so it's opposite the theta. Oh, that's our theta there, by the way. Let's label that. This is our opposite side, okay? This is our adjacent. It's the one closest to theta, so we're not going to involve that at all because there's nothing there that we really need to find. We want to find the H. We have the OH. Go back to SOHCAHTOA, SOH. That's going to be sine. So sine, okay, of 20 degrees, okay, is equal to opposite over hypotenuse. So 18 over A. Okay, now we have a bit of a problem here when the unknown, or the pronumerals in the denominator. What we can do, and there's multiple ways of doing this, is either you can put the 18 on top of the sine 20, and it's a bit of a shortcut if you like, or you can flip, basically invert both fractions, okay, and or treat sine of 20 as a fraction. I think it's quicker to do this, okay. I'm kind of just rambling on there. 18 over sine 20. There's your shortcut. As to the reason why, this is where equations are very useful. So I suggest if you don't know why I did this, go back and revise equations. Okay, so it's a very, very useful thing to know, equations. Okay, that aside though, if you just want to remember the shortcut, go right ahead. I like to know why things work, so that's how I like to do things. 18 over sine of 20. Yes, my calculator's in that degrees mode, of course. Make sure that's the right thing. And that's equal to 52.63, so I'll just leave it as 52.6. Okay. The triangle's not drawn to scale, so even though the triangle might look a little bit, sort of distorted, out of shape, how's that 20 degrees? It looks more like 30 degrees or 40. We don't care what the scale of the triangle is. We use the data or the how the triangle's labelled, or the data on the triangle. That's what we use. Okay, last one, part C. So, okay, I'm going to change the colour of the pen because red's getting boring. I'll use something different. All right, what do we have here? Let's label the triangle first. So, go at an angle, that's our theta. Okay, 30, that's the opposite side because it's well away, okay, from the angle theta there. And B, this will be our adjacent side, OA. Well, you probably see the pattern here. I used cosine here, sine here. Well, no prizes for guessing this one. I'll probably use tan, of course, because, I have to do an example on each one. But better reason aside, labeling the triangle, we have an opposite, adjacent. Hypotenuse doesn't even factor into this equation at all. It's blank. We don't need it for anything. So it's going to be 10, okay, from SOHCAHTOA. So 10 of, now, okay, this is what we call degrees, minutes, seconds, DMS, okay. So recall that there's 60 minutes in a degree and 60 seconds in 1 minute. So it's a way to divide up these degrees, okay, into 60ths. So 10 of 52 degrees, 34 minutes, okay, is equal to 30 over B, okay. All right. Now again, the unknown is in the denominator. All right, so we need to flip the fraction around, or we need to put the 30 on top of the tan 52 34. So B is equal to 30 over tan of 52 degrees, 34 minutes. All right. Okay. If you've forgotten how to use the degrees, minutes, seconds function on the calculator, okay. So we're going to do 30 over tan. Okay, now 52, we press this little button here that looks like so it's got the apostrophes and the degree symbol, and I'll just refocus that. Yep. Okay, so 52 degrees and 34 minutes. So we'll just press it again. Looks a bit off. It looks like 52 degrees, 34 degrees. It's not. The calculator will interpret it correctly. And press equals, and we got 22.96. Okay. All right. So that's equal to 22.96, and there's a few decimal places after that, but we want one decimal place. So the correct way to express that is going to be 23.0, because the 9, we increase the 9 by 1, becomes a 10. We carry the 1 over, it becomes 23. So we have to write it as 23.0. It's very important that you write the 0.0. It is possible to lose a mark because you did not, in fact, answer the question, which is correct to 1 decimal place.